Okay, so as requested, I'll be making a video showing why the sum of the roots of a quadratic equation ax squared plus bx plus c equal to 0 can be obtained by negative b or through negative b over a. This is the sum of the roots, while the product of the roots can be obtained using c over a. So this is the product of the roots. If you are familiar with these concepts, these are the formulas that you use in order for you to get the sum of the roots and the product of the roots without actually getting the exact value of the roots. Okay, so normally under a quadratic equation topic, if you're given say 2x squared plus 4x plus 3 is equal to 0, sometimes we don't we are not um, we are not interested in finding the roots, but what we want is the sum or the product of the roots. Okay, so the long way of doing it is find the roots, like solve this equation, and then once you have the two roots, then you add them, then you get the sum. You multiply them, then you get the product. Okay, but these formulas will easily find those values. So I got a request like, how can we show that these formulas or why are these formulas the ones that we use? Why not b over a? Why not negative c over a or other expressions? Okay, so that's my goal for this video, is to show you the reason. There are actually at least two um, ways of showing, so that's at least, meaning I know one and then I know another way, and there could be more than two, but in this particular video I'll be showing one of them, and then if I have time, then I'll show the other way, or meaning it's like a proof, like these are really the formulas that we need for the sum and product of the roots. Okay, so let's get started. So let's start with our general equation ax squared plus bx plus c equal to 0. So we have all the conditions satisfied. A cannot be 0, a, b, and c should be real numbers. Okay, so those are already assumed, okay, to be true. So what we want, so my way of showing why is it negative b over a and c over a is try to recall how do we like find the roots of this equation x squared plus 3x plus 2. So if you're listening to a teacher, then maybe you know that this should be x and 2 and 1, and then say equated to 0, so plus and plus. Then you check, this is 1x and this is 2x. Those two should sum up to 3x. Okay, otherwise you are getting the wrong factors. Okay, now as we can see, these are the correct factors, and from these factors we say x plus 1 is equal to 0 and x plus 2 is equal to 0. So x equals negative 1 is one of the roots, and x equals negative 2 is one of the roots. Okay, so if we want to get the sum of the roots, that's negative 1 plus negative 2, and this is equal to negative 3. Okay, the product is equal to negative 1 times negative 2 is equal to positive 2. And this should follow the rule or the formulas that we use. The sum is equal to negative b over a. So negative b, so our equation is x squared plus 3x plus 2. Our b is 3. So this will be negative of 3 over a, which is 1 from 1x squared. So 1. And we also got negative 3. And then the product is c over a. The c in the equation is 2. So you can see it here. That is your c. This is your 1. That's your a, rather, which is a 1. So this is 2. And this is 1. So the product must be 2. So it really shows negative b over a, c over a are the sum and the product of the roots respectively. Okay, so this time for the proof, what I want you to focus on is how I got the roots. Okay, to get the roots, I have to factor the expression. Okay, now what should we do since we have b, a, and c, or a, b, and c are any numbers? We cannot like think of what should be combined or what two numbers should be multiplied to get a, what should be multiplied to get a c. So we don't know exactly the numbers, but we can set these expressions or these values. Okay, and I'll show it now. So in the same manner, we'll be getting two binomial factors. So I'll try to be choosy on the values that I'll be using. For the ax squared, I'll set ax and x. It is correct. Ax times x is x squared. If you remember FOIL, FOIL is first and first, and you should get the first term of the quadratic equation or the quadratic expression. And then the last and the last will come from the c. Well, I will select c here, and this is 1. Okay? It's correct. Ax times x is ax squared. 1 times c is equal to c. Okay? Now, to make it easier for me to work with these variables or the numbers, the constants, let's set the operation to be plus. Okay? C could be negative, but we set it, the operation to be plus. Okay? Now, there's one important condition for this to be correct. Okay? Remember, you don't just select any combination of numbers. If you review the FOIL says, I'm not sure if you're familiar with the FOIL method, it's a common way of expanding expression. So the FOIL is one way of multiplying expressions. This O means you multiply the outer, ACX, that's ACX, and then the inner, these two, will be 1x. Okay? And for these factors to be the real factors of ax squared plus bx plus c, the sum, remember the sum of x and acx, x plus acx, must be equal to the middle term. Right? That's what we did in the x plus 1 and x plus 2. See? You cannot just select minus 1, minus 2. You have to consider the expression in the middle. You need a 3x. So to get a 3x, you need an x. And you need a 2x. X and 2x can be obtained when this is x plus 1 and this is x plus 2. And no other combination. Okay? So this x plus 2x must be equal to 3x. In terms of a, b, and c, that means the x, see this? The acx and the x should be equal to the middle term, which is equal to bx. If you simplify this, you should see that this is 1 plus ac by factoring out x is equal to bx. By correspondence, 1 plus ac must be equal to b. Is that correct? 1 plus AC must be equal to B. So I need you to take note of this. This will be very important when we close the proof, okay? On why it's negative B over A and C over A. So take note of this equation. This is very important. Okay, let's go back to the roots. So if the factors are ax plus 1 and x plus c, the roots can be obtained when we set these two factors to 0, because they will make it 0. And the first one is x equals, or ax is equal to negative 1 and x is equal to negative 1a. This is one of the roots. We don't know what's a, but we know it's in the form of negative 1 over a. X plus c will give us the root negative c, right? If we solve the equation x plus c equal to 0, so the other root is negative c. Okay. Now, you'll be surprised. Remember, the goal is finding the sum and finding the product. The sum is literally the value when you get that you get when you add the two, negative 1 over a plus negative c, right? Okay, look at this. I'll be combining these two. Well, denominator LCD is a divided by a times negative 1 is negative 1, a over 1 is a times negative c is negative ac. Let's simplify this further. Factor out the negative 1, or just negative sign. You get 1 plus ac over a. And then I need you to look at this expression. Is this familiar? 1 plus ac, according to our note, is equal to b. So now we replace 1 plus ac by b. So this is negative 1 plus ac is b over a. So this is equal to negative b over a. This is the sum of the roots, the formula that we use. Okay? And then we go to the product of the roots. Again, don't forget the roots are negative 1 over a and negative c. So how do you get the product? You literally multiply the two. And when you simplify this, negative and negative becomes positive. 1 in c is c, and then a times 1 is a. And this is your c over a. See? That's the formula in finding the product of the roots. Okay, so this is one of the, I don't know, I know two ways of showing why is it negative b over a and c over a. So in this approach, I use the concept of factoring. I followed how we factored an example like x squared plus 3x plus 2. Now generalizing that to ax squared plus bx plus c, I was able to show that the sum is really negative b over a, whatever the value of b and a, and the product is c over a, whatever the value of c in the ax squared plus bx plus c equal to 0. Okay, so I hope I was able to help you understand why these are the formulas for the sum and the product of the roots. Again, this is not like a test question. This is just more an understanding why are we using negative b over a and why are we using c over a. If your questions are like finding the sum and the roots, sum of the roots and the product of the roots, you basically use these formulas and you can find those values. Okay, that's it.